Hi guys, welcome. Today is day 27. We're looking at two lessons today. We're doing lessons 74 and 75. So lesson 74, fractional parts of numbers, part 2. We've done this in the past. This is just going beyond what we've done in the past. So again, we'll see a short word problem like this, like we've had the what numbers, what percents, what fraction, of means multiplication, and then is means our equal sign. So we can pretty quickly put this into an equation. If we have what fraction of 56 is 42, what fraction, okay, I'm just going to call it x, you can call it WF or F or Z or whatever you want to. What fraction of 56, what number times 56 is, and what was our number? Is 42. Well, we know we're multiplying, so I need to divide. Okay, I get x or WF or whatever we're calling it by itself. And then here's our fraction. We can obviously reduce that down. What do we have? 7 goes into both of them. 6, 8, and then that can reduce down because 2 goes into both of those. So 3/4. So what fraction 3/4 of 56 is or equals 42? So that fraction we were looking for is 3/4. Again, make sure that we reduce. Don't put 42/56. That's not what we're looking for. We want to reduce it down as much as we can. Okay, and then if it was asking for the same question, what decimal or number, if it didn't say, it just said what number, and you could give it as a fraction or a decimal, the equivalent of 3/4, if we did 42 divided by 56 and came up with a decimal, would be 0.75. Okay, we may be given the fraction 3/4 of what number is 60. 3/4 of, so that's multiplication. What number is or equals 60? Again, we're multiplying, we're given a fraction, we are multiplying, so we need to divide. And we remember when we divide by a fraction, that's the same as multiplying by the reciprocal. So 3/4 divided by 3/4 is 1, but that's also the same as multiplying by 4/3. So I multiply both sides by the reciprocal because that's going to cancel out there and there. So I get my number by itself. 3 goes into 3 once, into 60 20 times, 20 times 4. That number is 80. Okay, so 3/4 of 80 is 60. So again, always just go back to the original word problem. Does your number look right and make sense? In this case, yeah, 3/4 times 80. Yeah, that would give us 60. All right. The number is 80. Again, if we were doing a decimal, it's at 3/4, so we can make it 0.75 and do the same thing. 60 divided by 0.75 is 80. So if it says what fraction, and let's write it as a fraction. If it just says what number, we come up with a decimal or a fraction, unless it specifically says, I'm fine with you putting either one. All right, practice set we'll do together. Second item we're looking at today is area of complex figure and area of a trapezoid. So a complex figure could just be some polygon that isn't, it's got 5, 6, 7 sides, but it's not, the triangle or rectangle or just a typical polygon that we're used to working with. So we're going to need to break it apart into some different. Instead of me trying to draw this out on the whiteboard, let's just look at it here. So we have 7, 16, 10, and 4. And then we know if we were to carry this line straight down, well, this is 4, this is 10, so this would have to be 6 right there. And this is 16, this is 7. Okay, so we could draw it out and do a large polygon and then find the area of all of it and then subtract. I think it's going to be easier to break it apart into 2 polygons, probably a triangle right here since we know this distance. And that gives us a 7 by 10 rectangle. Pretty easy to calculate that. And then a 9, because this was 7, this was 16. So this distance from here to the end is going to be 9. So that's how we got that distance right there. So 9 times 6 divided by 2 is going to be 27. And then we add the areas of the 2 separate polygons together to get us the total area of the polygon, which is 97. And it was millimeters, so square millimeters. Again, we've done this in the past. We can also do this by finding an area of what would be a larger polygon and then subtract the missing part to get the actual. So like this, if we were to carry this side out to a corner, meet it with that corner right there, we would have what, a 10 by 10 square. So we can find the square and then find the area of this missing region and then subtract it. Nothing wrong with that. I think that might be a little bit more work. We could divide it into a rectangle right here and then cut it across here. So we had a triangle. We can divide it, into a rectangle right here, a rectangle right here, and then this triangle right here. Again, as long as we're doing the math correctly and dividing it up correctly, we can do it into 3 different shapes, 2 rectangles here and a triangle, 2 rectangles here and a triangle, or find the area of the entire square and then find the area of this triangle and subtract it from the 10 by 10, which would be 100 square centimeters. And so either way, we should get to the same thing. This way, we have a 6 by 7 triangle, or a 10 by 3, and then a 4 times 7, and then divided by 2 because it's a triangle. And 7 by 4 divided by 2, a 3 times 4 rectangle, and then a 6 times 10 rectangle. It's going to add up to be the same thing no matter what we do. So either method, you see one of these, and I do it a way different than you. As long as we both do it correctly, we should end up at the same answer. All right, then area of a trapezoid. We've worked with quadrilaterals in the past. A trapezoid is a quadrilateral, but it's a little unique. It's not the same as a rectangle. It's not the same as a parallelogram because we do have 2 sides that are parallel to each other, but the other pair of sides, if we were to continue on this side and this side, they would eventually cross. So it's not a parallelogram, and that creates an issue because we can't just do base times height. If we did this base times this height, this would be our area, which is too large. If we did this base right here times this height, it wouldn't be enough. Okay, so we're going to have a rectangle that's too large and one that's too small. So how do we find? It's going to be somewhere in the middle. Yeah, it's going to be in the middle. So we take the average of the 2 bases. So we do base 1 plus base 2. Again, if you want to call this base 1 or base 2, it doesn't matter. We're adding them together and then dividing by 2 because we're finding the average. So base 1 plus base 2 divided by 2. Don't forget to divide by 2 because we have to find the average and then multiply it by the height. So if this is our trapezoid, again, it doesn't matter the orientation. It could even be tilted to its side. It's still a trapezoid. Okay, we have 10 and 7. So 10 plus 7 is 17 divided by 2. What is that? 8.5. And then we do 8.5 times the height, which is 6. And we get 51. So 8. Let me check that. Okay, 8.5 times 6 does give us 51 square centimeters. So this is the formula. It should be in your reference sheet. You can just flip over, find the area of a trapezoid. It may show it as base 1 plus base 2 all over 2. So being divided by 2, multiplying by 1/2 and dividing by 2 is the same thing. So just similar to when we talk about a triangle, 1/2 base times height or base times height divided by 2. It's the same thing. So don't let that throw you for a loop. That is our And then if we wanted to estimate area, if we were just trying to find, buy supplies and make sure we had enough and we estimated, we could round to 10 and 6 and 7 and do 10 plus 6 is 16, divided by 2 is 8. 8 times 7 is 56 square feet. So again, only estimate if it says to estimate. Otherwise, we're going to have to calculate it out. All right, this practice set we'll go over together. And we're probably only a few days away from the end of the semester. So hang in there. You guys are doing a good job. We'll see you soon.